Okay, so this is going to be electron configurations. I'm going to talk about how to take the periodic table and turn it into a essentially how to get an electron configuration from it. So we're going to break, first of all, every single periodic table is going to have this. This is a very blank periodic table that I have, but you're always going to be able to number across the top 1, 2, 3, 4, 5, 6, 7, 8, all the way across 11, 12, 13, 14, 15, 16, 17, and 18. So these are the group numbers. This is, again, that is a group. Okay, so these are the group numbers, and they're going to be important. The other numbers that I'm going to put in are from left to right, 1, 2, 3, 4, 5, 6, 7, and these go in this direction. So that is what we call a period, okay? That is going across. Again, we've talked about this before, but so this is period 1, this is period 2, this is period 3, so on and so forth. And what we're going to notice is there's a little bit missing here. Lanthanum actually goes down to here, and that's the next one. Then we go across here, and then once we get to lutetium, we go up to back to hafnium, and that's it. So this kind of whole thing actually gets inserted right here, and it would stretch the periodic table. So because this is row 6, and this is row 6, this right here is going to be 6 as well. So 6 and 7. So that's how it's broken down. Generally, the numbers, the period numbers are not there, but the group numbers are. So the next thing that I'm going to do is I'm going to divide up the periodic table. I'm going to take helium, and I'm actually going to put it over here. And you'll see why. It will make sense kind of when we put this whole thing together. So I'm going to isolate these first 2 groups, okay? And I'm just going to put a little box around them. I'm going to highlight them. This little this little spot here is going to be our first little grouping of atoms. We're going to call these things blocks. And this thing is going to be known as the S block. Okay, the S block is essentially one row it's all of these here, and each row is going to be its own portion of the S block. I'm going to put this little number down here, N, and that will make sense in a little bit. So here's my S block. Okay, so within the S block, we have numbers. So this first row right here is the S block. It's also in the first period. So we're going to call this the 1 for the first period, 1S. So this is the 1S block, okay? So that's the 1S. This one would be the 2S, and 3S, 4S, 5S, 6S, 7S. So there we go. So that's the S block. Each one corresponds, and this is where this N value, each number corresponds to the period out front. So 1S, 2S, 3S, 4S, so on and so forth. So that's the S block. The next little setup is I'm going to highlight, or I'm going to isolate this little group right here. This is the next block that we're going to take a look at. This is known as the P block. The P block is going to also have an N out front. Okay, so the P block, again, I'm going to isolate the P block. Let me do this. Here we go. So the P block is going to be all of the elements over in the this side, 13 all the way to 18. Okay, so it includes all of this stuff. And again, same idea holds true. I would like to point out that, again, this right here is the second period, and this goes across, and this is also the second period. So I'm going to put that 2 in front of here and the 3 here. Okay, so we know that that's the second period, the third period, the fourth, so on and so forth. So unlike the S block, where it starts with the 1S, because of the N, the first P block is actually the 2P block, just because there is no 1P because there's no P up here. So we're going to call this thing the 2p, okay? And the next one is 3p, 4p, 5p, 6p, 7p. Okay, so again, that's the p block. Okay. The next little setup we're going to take a look at is the thing that's kind of downset down here. It's kind of a little bit lower. This is going to be known as the D block. Things are going to change just slightly. This is actually n-1, meaning the number out front for this one is actually going to be, we're going to subtract 1 from the total, and we'll see what that means in just a second. Let me highlight this. Go. Okay. All right. So because this is the 4s, this is also in the 4 row, and this is the 4p. But the difference is, because this is 4, it's going to be n-1. N-1 meaning what we're going to do is we're actually going to call this the 4, or I'm sorry, not the 4d, n-1. So if it's 4 out front, we're going to call this thing the 3d. I love that color. Let's try. Okay, so we're going to call this thing the 3D. So this is going to be the 3D. The next one, again, 5s. This is n-1, so the number out front -1. So this becomes the 4D. Okay, so this is the 4D, 5D, and 6D. Okay, and that last little bit, the little side down here that I mentioned, the little portion that I mentioned kind of was off on its own. This section down here is going to be known as the F block. And this one is going to be n-2. So the F block being n-2 is basically just going to be the number out front. You're going to notice that 6 out front. So that's going to make this thing, because this is a 6 out front, this makes this n-2. So 6 minus 2 makes this the 4f. Okay, so this right here is the 4f. And that makes this the 5f. The last way to recognize that, 1s, 2p, 3d, 4f. Every single time I jump a block, I lose a number. I can have a 1s, I can't have a 1p. I can have a 2p, I can't have a 2d. I can have a 3d, I can't have a 3f, so on and so forth. Okay, so 1s, 2p, 3d, again, the n out front will tell you about it. Okay, great. So we're partially the way there. Each of these blocks is going to have a specific number of electrons isolated to it. And we can figure out the number of electrons that fit in each block, each row of each block, just by counting. So how many elements do I have? I'm just going to zoom in here. I have, if we look at row 2, 1, 2 elements. Every single one of those is going to get 2 electrons. So sodium, magnesium, potassium, calcium. So every single row in the S block is going to can hold a total of 2 electrons. How about the P block? How many elements do we have? 1, 2, 3, 4, 5, 6. So that means the P block can hold 6 electrons. How about the D block? How many electrons can fit in the D block? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can fit 10 electrons in the D block, and I can do the same thing down here, 14 electrons in the F block. Okay, good enough? All right, so we're going to do an electron configuration. There's the longhand notation and the shorthand notation, and we're just going to pick one and we're going to do how these things fill. Okay, so I'm going to choose something pretty simple, something that has kind of all of these blocks in it. Actually, let's do the filling order, this little thing down here. Okay, so the first thing that fills, the very first electron goes up here, right? So the first thing that fills up is the 1s. So the 1s is the first thing to fill. How many electrons fit in there? That's right, 2 electrons fit in because it's in the s block. So go over here. We're at the end of the line, so we start down here again. Next thing to fill up is the 2s, and 2 electrons can fit in there. So 1s, 2s, the next thing that fills up is going to be the 2p. Okay, so the next thing that fills up is the 2p. How many electrons can that hold? 6. After the 2p fills up, we come to the end of the line. So we start in row 3. The 3s is the next thing that fills up, and then the 3p. So 3s, which can hold 2, 3p, which can hold 6. And now once we get to the end of the line here at the 3p, we start in row 4. The 4s is the next thing that fills up, and this is where it's going to get somewhat interesting. So the 4s, we can put 2 there. And once the 4s is full, then we start filling our first D block. We notice that the number changes though. So once this starts to fill, we're starting to fill the 3D until we completely fill it up. So we go from the 4s up to the 3D, and we can put 10 there. And then after we fill up the 3D, we start to fill up the 4p. And next thing that can fill up is the 4p. 4p fills with 6 electrons, and we go. So pause it and try to kind of work your way through the next line. And let's see if we can get there. So after the 4p, we're going to fill the 5s. 2 electrons fit there. Once the 5s fills up, the next thing is the 4d. 4d fills up next, 10 electrons there. 4d fills, then the 5p. Notice how we drop to do the d, and then we jump to do the p. And after the 5p, we go back to 6s. So now it gets a little bit interesting. So now once we have filled up the, let's see, 5p, and now we're on to 6s. So now we're going to jump here, okay? And then we go down to this spot, and so we put 1 electron in the 5d weirdly, and then the 4f fills up. But the 4f is going to completely fill up next. So I'm going to say that beyond the 6s, and I'm going to need a little more space for this. So the 4f14 is the next thing that fills up. And then once we get to the end of the line here, we have to go back up and start filling up the rest of the 5d. So the 5d10, after the 5d10 fills up, we start filling up the 6p. So 6p, 6, and then we start again. So let's just finish this off. 7s2, 5f14, 6d10, 5d, yeah, 6d10, 7p, 6. Okay, and that's it. That's the configuration. In fact, this is the exact configuration. You just end up stopping somewhere. So that is the full configuration of the periodic table. It will always fill in that order. So if I choose something like, all right, let's do the electron configuration of molybdenum, MO. Okay, again, we start 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So we have filled 3s2, 3p, 4s2. We filled up the 3d, now the 4p, and now I am on my last line now. So once I get to the 4p, the next thing that fills up is the 5s. So the 5s2 fills up. And now 5s2 is full. I'm here, and I'm going to put 1, 2, 3, 4 electrons because I'm going to stop at molybdenum. So 4 electrons in that 4d. So 4d10, and then we're done. Or I'm sorry, no, that's too many. 4d4. There we go. 4d4. Now we have 4 electrons in the 4d. That's it. That's how we do an electron configuration of an atom. Okay, and there's some examples on the next page. So give those a go. I will complete them so you can take a look, but that's what we've got. The last little bit, this is the long version of the electron configuration. I'm going to do the shorthand notation because it's going to make life really easy. Ultimately, I only care about the last row. So all of this stuff always feels the same. So 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then and so on and so forth. So we keep filling in that order every single time. Okay, so because we fill in that order, we know that whenever we get out to the end, everything before it is always going to be the same. So what I want to do is for molybdenum, here's my molybdenum. I am going to, in fact, let me just highlight it so we can see it. There's my molybdenum. I am going to look on the previous line. So if you go up one and you go all the way to the end, I have krypton. So instead of filling all the way up to krypton, and that would be, again, filling to kryptons 1s2 or 1s, 2s, 2p, 3s, 3p, right? So well, let me do this again. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. So essentially, I've filled up all the way up to here. Okay, so that's going to be the same for anything on molybdenum's line, or beyond, really, but everything is the same. So instead of writing all of this, I can simply shorten it. In fact, I'm going to do that. So that stuff right there just simply gets shortened, because what that really is just the electron configuration of krypton. So I can actually take krypton, I can put it in brackets. Those two things are going to be the same thing. So the krypton in brackets means, so this is the same thing as writing this. So to shorten things up, I can get myself to the end of the line here. And now, because I'm at krypton, the next thing that fills beyond krypton is going to be the 5s. And so that's where we can actually start. So the shorthand notation for molybdenum is the configuration of krypton in brackets 5s2, 4d4. These two things mean the same exact thing. Okay, so that's what we're looking for. All right, good. The last little bit, although I will totally accept this, and most people will accept these things, the more correct way of writing the shorthand notation is just to take the more correct way of doing this is to take your order and actually order them by number. So notice how I went 5, 4. What I really want to do is I want to switch it so it's 4, then 5. So just reorder the numbers so it's, lowest to highest, and that's technically more correct, but this is totally okay too. So yeah, that's how we do electron configurations. And they're actually pretty simple. So that's what we're looking at. So let's take a look at oxygen. I'll just do one of these for us. Let's take a look at oxygen and the shorthand. So let's take a look at where oxygen is. So oxygen is here. Sorry, I can't see it. So that means I'm going to fill the 1s, I'm going to fill the 2s, and I'm going to have 1, 2, 3, 4 electrons in the 2p. So for oxygen, you should have 1s2, 2s2, 2p4, and that's pretty much it. To do the shorthand electron configuration, we're going to take a look at oxygen. The thing on the previous line is helium, so I'm just going to simply put helium in brackets. And I'm going to say 2s2, 2p4 is the correct answer for that one. And that's pretty much it. Okay, so that's pretty much how these things are going to fill. If we want to take a look at another one, let's take a look at potassium. So potassium is here. Okay, so I'm going to fill all the way to the 4s. So 1s2, 2s2, 2p6, 3s2, 3p6. And so now I'm all the way out to argon, Ar. Okay, and so the next thing that goes, we start to fill this, but actually I only need to put one in 4s1. I just need one electron in that 4s. Again, because we filled out to argon, I can do the simplified version of this, simply argon, and then we can start from argon. 4s1 is the configuration. So that's the idea behind electron configurations. We can just write them based on this. Start here, work your way across, and just keep going across until you get here, you jump down, back up, and so on and so forth. So that's how electron configurations work. Good. The last little bit, having a charge, calcium 2+, vanadium 3+. I'm positive I lost an electron. So if it's positive, it means it lost an electron. Okay, so I'm positive I lost an electron. What I see by having this +2 charge is it lost 2 electrons. So what I want to do is I want to find calcium and I want to go back 2 elements. So calcium 2+ has the same electron configuration as, so here's my calcium. If I go back 1 and then to previous line 2, it's going to have the same exact electron configuration as argon, same as a neutral argon. So just write out the electron configuration of argon. Okay. The negative charge means that you gain 1. So just move forward 1 electron or 1 atom, and that's the electron configuration. So that's it. Those are electron configurations. They're straightforward. The last little bit, we are going to talk about periodic trends in the next video.